Good morning to all. I am ARAVINDAGURU, Assistant Professor, Senior Grade from the Department of Electronics and Instrumentation, Sri Ramakrishna Engineering College, Coimbatore. Today we are going to discuss on an interesting topic from industrial automation. That is nothing but controller for automation. Controller, before going for a controller, we will see about what is industrial automation. Industrial automation is nothing but to automate and machineries and the process in the industries without the intervention of humans. Next we will see about an controllers. What is the importance of controllers? Controllers is nothing but it is going to automate and it will verify whether the given set point is attained or not. That is the process variables, that is your output. Output should be compared with your set point and whether it is equally that is error is getting reduced. It is the main function of your automation. We will see about an automation. Automation is nothing but it is reducing the human intervention and making the things easier and quicker and then the accurate. It will automates the machineries with the control with the help of controllers, and it will make the process quicker and the innovation thinking will be happened. The AI also will be getting collaborated over here and the autonomous process will be taken over by using an automation. The productivity also getting increased in the usage of automation and the repeatability also will be done by using of the looping processes, and the improvement in the production also will be happened by using the automation in the industries. Then we will understand about automation. Then we have discussed about the automation. Then we will see the advantages of automation, that is the increase of productivity and increasing the quality, reducing the cost and increasing safety in working conditions. But automation is not alone enough. We have to introduce an controller over here to control the process and make the things safer and accurate. So we can see about that controller is the heart of automation. Now we will see about an controllers. In the controllers, these are the systems available in the controllers. First we have to give an set point which is a desired value. Next is an process or plant which is used to the process nothing but temperature process, level process, flow process, or which parameter you are going to control is the process or the plant. Next one is a major role is an sensor which will measure your outputs whether the desired set point is correct or not, which will matches the output is matched with an set point or not will be ensured by using an controller and then the set point. Then actuators is used to implement the decisions whether the for example we will take an pumps, motors, and example the output devices are termed as an actuators, the input terms are termed as an sensors. Here sensors is used to give an set point and it will ensure that whether the physical parameter is running in an desired value or not. So the controller is very much important in the automation. Let us see why we are going for an controller. For us we will take an scenario. Here we will take an 3 scenarios. One is about an tank filling process, then air conditioning temperature in an room, then by using an motor how much it is getting run, how much speed it is getting run. First of all we will see about an room temperature by using an air conditioner. Now we will set an room temperature at 24 degrees Celsius by using an air conditioner. Here how we can maintain that exact temperature. Next scenario is when a motor in an industry runs at 1500 rpm, how does it stay at the set point and without even if the load changes also the speed will be maintained at the same level. Next we will go for a third scenario, that is when a water tank fills automatically and stops at a particular level. Who is making that decision? What will be the answer for these 3 scenarios is nothing but it is a controller which is very much useful in our automation and it will controls the overall process and it will maintains the accuracy and then the process flow. Next, these are the advantages of the controllers used in the industries. That is, it is a simple output which matches the desired value. The values will be, desired value will be matched with an output, and then the errors are minimized over here, and the disturbances are getting corrected. It will be getting predicted, and it will be, disturbances are eliminated over here, and then the safety is maintained and performance is optimized here. These are the basic concepts of control system. Let us see about the controllers which are available in the industries. First of all, we will see about an basic controller in industry, which is a robust one, and also a basic controller in industries. That is nothing but it is an programmable logic controller, that is PLC. It is termed as an PLC. The PLC is nothing but it is a microprocessor that is used to store the instructions, and we can perform the logical functions and counting functions and then the timer functions to control the process within the desired value. And it is also used to monitor the crucial process parameters and can adjust the process operations accordingly. And is also a industrial computer that monitors inputs and outputs to make the decisions with the desired set points. And also it is used to reduce the human interventions and to gain the higher efficiency. Next, we will see about an architecture of PLC and what are the components available in the PLC. These are the components available in the PLC. First one is input module, then output module, then power supply for the whole process, then programming devices to perform the programming and to develop an logical operations, then optical isolation to isolate and to protect the circuits. We are using this optical isolation. Then CPU is for the processing the whole process, and the memory to store the program memory, and the data will be stored in these memories. Here input module and then the output module is used for the interfacing of sensors and then the actuators. That is nothing but you are going to interface the input sensing devices with the input module. In the output module you are going to interface with an actuators like pumps, motors, relays and switching devices, etc. Then we will see about an CPU. CPU is consisting of three subparts. First one is microprocessor, which is used to processing purposes. Next one is memory for storage devices, and then the temporary memory actions, and then the power supply for the whole power. And then the input output sections will be used for interfacing and hardwired like components like sensors, transducers and transmitters and switches for an input purposes. For output purposes we will connect it with then actuators like pumps and other actuators. Then programming device like PC or handheld devices, we can do our programming for the controller. Then it is about a brief explanation of CPU. It is a brain of the PLC, and also it will accept the input data from the sensing devices and executes the stored user program, and also it will sense the appropriate output commands to the actuators or the control devices. And these are the other units available in the CPU, that is control unit to control the process. Arithmetical logical unit is used to get the information from the inputs, and then it will do an arithmetic operations like addition, subtraction, multiplication and other logical thinking will be done in an arithmetic control. Next one is an memory unit is used for an storage purposes, and then the outputs will be controlled or it is attached with an control unit. Then these are the types of memory units. One is the programmable read-only memory and erasable program read-only memory. Then EEPROM, that is electrically erasable programmable read-only memory. Non-volatile random access memory, that is an RAM, that is a temporary storage. Others and all, it is an permanent storage. We can erase by using an electrical signals or by an signals. Then next we will see about a detailed view of an input output module. First we will see about an input module. In the input module there will be a common power buses will be available, which will be connected with our input field devices like relay contacts, push buttons, limit switches, analog sensors, etc. And also we will be having common return buses which will be connected with our user power supply and also with an isolation circuits, optical isolators. And these are the input module block diagram. Here we will be using an input signal, that is the sensor signal will be given to our bridge rectifier. We all know about the rectifiers. It will be converting our DC supply to an AC supply, that is AC will be converted to an DC by using this bridge rectifiers, and the noise filters will be used, which is used to filter the unwanted signals and the noises over here. Then threshold level detection is used to, it will detect an the prescribed threshold values alone will be given over here, and the isolator is used to communicate between the two circuits. Then it will be connected to the processor. Isolator will be connecting this input module circuits with the processor. Then this is an output module. Here output module is also having a common return bus, and it will be having an user power supply for the power supply over here, and it will be connecting with that or communicating with an output devices like relays, motor starters, solenoid valves, indicator lights, LED displays, etc. And these are the symbols of input or output devices. First one is the overloads. Here the thermal device output device will be termed as this symbol, and contacts is of two types, normally closed and normally open contacts. This is used for an input power supplies, and the input sensors will be termed as this normally open or normally closed. Next one is push buttons. It is also representing the normally open and normally closed. Next is the switches will be termed as these symbols, and then the next is a fuse, which is used for an fuse purposes, and coils, which is termed as an output. Coil is otherwise termed as output, so it will be represented here as this symbol. Then motors will be represented in the three-phase motors, means it will represented as this symbol. Then the transformer, which is used for an switching purposes. Then we will see about an till now we have discussed about the architecture of PLC and what are the components available in the PLC. Now we will discuss about what are the programming languages available in this PLC. There are 5 programming languages available in this PLC. First one is ladder diagram, next one is function block diagram, third one is instruction list, fourth one is sequential function charts, and fifth one is nothing but it is an structured text. First we will discuss about an ladder diagram. That is nothing but it is like a ladder. All I think so all know about the ladder, how is the structure of ladder is, and also the railway tracks. These are the structure of our ladder diagram. It will be having rails in the vertical line, and in a horizontal line we will be having our rungs. We will see about that ladder diagram. This is the structure of ladder diagram. The vertical line will represent the rails and the horizontal line will represent the rungs. And it is a very commonly used PLC programming language, and it is like a switching circuit, and here the program scanning will be from left side to right side and top to bottom approach. Here the first rung will be scanned first, and next it will be coming to the second rung, then third rung, and to the last rung it will be getting run from top to bottom, and left to right approach will be done over here. These are the rules for the framing ladder diagram. Here also it is terming as power rails. The vertical lines will be your power rails, and horizontal lines will be your rungs, and the scanning will be from left to right and top to bottom approach will be done over here. and also the after the every execution is done, the command will be executed and will be terminated from the programming. And also the inputs and outputs should be determined in the program. The inputs is termed as an contacts, output is termed as an coils. Then inputs will be placed in the that means the contacts is placed in the left side and the coils will be placed in the right side of your program. I will show you the demo over here, and these are the ladder symbols we are using. The first two things are the inputs, the third one will be your output symbol. First one is an normally open input connection, second one is normally closed input connection, third one is your output connection. First two are the symbols of contacts, third one is your coil, and these are the start of the junction and the end of the junction, and then the connector lines. This is the symbol of your ladder diagram. First one is input, second one is your output. First symbol is representing the normally open with your output, second diagram will representing your normally closed type input with your output. Here in the next we will go with an logical functions and all. Before that we will know that the normally open will represent the zeros and the normally closed will represent the one value. That is, in the digitals we will be having dealing with then zeros and ones. Here zeros are represented as normally open contact and 1 is represented as normally closed contact. Here output will be termed as this symbol that will be placed in your right corner. Then we will see about logical functions. In the logical functions there are 5 types. Mainly we will deal with AND gate, OR gate, NAND, NOR and NOT, and XOR we will be dealing occasionally. First we will see about an AND gate. AND is nothing but it is an multiplication, and OR gate is representing your addition purposes, we will be using our OR gate. NOT is the inverse purpose, we will be using NOT gate. Here in the AND gate it will be represented as this figure. Input A and input B will be in this structure, then output will be placed in the right corner. Here 0 and 0, first truth table, we will take this truth table. In that 0 and 0 will be your inputs. So we have placed the 2 normally open contacts and 1 output will be represented here. Next, if you are going for an 0 and 1s, we have to use normally open and normally close for 1. This is how we are going to perform an AND gate. Next we will see about an OR gate. Here the representation will be different. Here we are going to perform an addition purpose. So the input will be A will be given in the top. Next line we have to represent our input B. This is the structure for OR gate. Here the addition purpose will be happening. Here also if we want to represent the 1 value, we have to give an normally closed contact. Next we will see about an NAND. In the NAND nothing but we have to use an in the AND gate we have to use an inverse symbol after the AND operation. Then it will be doing the inverse purpose, we are using that inverse symbol here. Next is this is the NOT gate. If you are giving your input as 0, if you are giving inversing it, it will be output will be your 1s, and if you are giving 1 as an input, the inverted value is 0 will be represented here. Next we will see about an important purpose is latching. For this we will take an example for where we want to use the latching is, if you want to hold your operation or your output in an energized state, we can use this latching. For example, we will take push buttons to switch on your electrical motor. Here in the electrical pump, we will be using your push buttons here. In our household devices, we will be using our pump. In that we will be using green color push button and then the red color push button for switching purposes of our electrical motor to pump the water from the sump to overhead tank. Here we will be pressing an green color push button. From here, the whenever we are pushing only, it will be getting energized until we are going to press the red button to stop the pump. Until that time, it should be getting hold in an energized state. Our push button should be in our energized state. So for that purpose, we will be using this type of latching. It will be, the latching is nothing but it is a condition which will hold your output in an energized state until you are pressing the emergency stop or the stop button. Here the input A contacts are closed, then whenever we are going to press the red button, till that the state will be in energized. Whenever we are switching that red button, it will be changing from that hold state to the stop state. This is explained over here. The latching is nothing but we have to call upon the output in the contacts. Actually we will be calling that output in the AND gate, input A and in output will be in an OR gate type. It will be represented over here. This is representing our latching. Whenever we are input is added or and we are going to OR gate performance has been done with the output and input, it is termed as an latching over here. This is explained over here. Next we can use an single inputs and multiple outputs. We can use one single output and we can use multiple inputs in an, right, and but in a single rung we cannot connect more than one outputs. We can use many rungs and we can connect with our input, but in a single rung we cannot connect the many outputs. That is explained over here. Then the next important topic in our PLC programming, that is in the ladder diagram, is timers. Timers is nothing but it is an, by using a timing operation we are going to control a process. For example, if you want to switch an motor after 10 seconds or after 1 minute, means we can set the timer time in our timers. Then after switching purpose, after the switching, after delay seconds only, it will be getting, the output will be getting triggered over here. For example, if you want to switch on the motor, you can switch at a time at 10 o'clock, means the motor has to be getting switched on at 10:05, means you can set the time as 5 minutes, delay time as 5 minutes. After 5 minutes only the motor will be getting switched on. The delay purposes we can use this. We can delay and you can off or on the process by using this type of timers. There are 3 types of timers are available. One is on delay timer, next one is off delay timer and retentive timers. Here on delay timer means we can provide time delays when the relay is energized. Then if we want to switch off the device by using the delay, means we can use this off delay timer, and a retentive timer on is used to reset the timers. And we will see what are the quantities which will be available in timers is preset timer, accumulated timer and then the timer base. Here the preset timer means for how much the duration the time should be getting run is used as an preset timer here. Next the accumulated time means it will represent the how much seconds has been elapsed from the start timing will be represented in this accumulated time. Next one is timer base. Here we have to give from which second the timer has to be get switched on. That is nothing but if we want to start from 0 or from particular seconds, we can set over here. These are the representation of timers. Here the first one, the control line and then the reset line will be there. Here we will be representing the preset time, timer base and accumulated time. Then the output will be connected with your timers, so that the output will be controlled based upon the timer set in the timers. It may be an on delay timer or the off delay timer. Next we will see about another important topic in ladder diagram is condition is counter, which is used to count the number of events happened. That means nothing but if you want for counting purpose we can use this counters. For this we can take real time examples. In food industries or packaging industries, there will be an packaging will be moved on the packing section. Here it will be the products will be moved in an conveyor belt. At that time, how much packages has been run or it has been dispatched will be counted by using the sensors will be getting used to sense the how much packing has been done, and then whenever the sensor is getting sensed, the counter will be counting the event. How much parts has been sensed will be termed as or converted as a count over here by using the counter. In the counters also there will be three types of words will be available, that is the contents will be available. One is the controlled word, and then the preset word or an preset value or accumulated value. Here also the controlled word will be your counters, and preset value is your how much seconds it has to be set, and accumulated word value will be your how much time has been elapsed or how much count has been elapsed here will be termed in the accumulated value. And this is the representation of the counter. Here also the preset value and the type of counter and accumulated value will be represented here. Then we will see by using an timer we will see one real time example, and the programming also we will be explained in this section. Here the sequence program for motor control. We want to control these three type of motors based on the timer. The condition is nothing but we have to start these three motors sequentially with the delays. The condition is starting the oil motor, that is Y0 is the oil motor will be started whenever we are pushing the start X0 button. In the start X0 button will be pushed. Whenever it is getting pushed, the motor will be getting switched on. Y0 will be getting switched on. The main motor, that is the Y2, will start after the 10 seconds. Then the auxiliary motor Y1 will start after the 5 seconds whenever the green, that X0 is getting switched on. Then whenever we are going to press X1, that is the stop button, immediately the all motors Y0, Y1 and Y2 should be getting switched off over here. For this we will develop an ladder diagram, and I will explain you what is the function of that ladder diagram and how it is getting performed also will be explained here. This is the program, ladder diagram program to control the sequential motors. First of all, we will take X0, that is an start button. It should be in an normally open type. Whenever we are going to press only, it will be converting from a normally open to normally closed type. So we will represent it as an normally open type. Next we are using an stop button. X1 is your stop button. Why we are specifically doing it in every rungs means for emergency stop. Whenever we are pressing X1, the three operations should be getting shut down. So only we are represented the X1 in every rungs. Next one we are going to give a timer. Whenever the X0 is getting pressed, the timer will be getting switched on. For 10 seconds it will be getting run. That is T0 is your timer, it is set for 10 seconds. After 10 seconds only the motor will be getting switched on over here. That is your Y0 will be getting switched on. First of all, the Y0 is connected with our X0. Whenever the X0 is getting switched on, the Y0 oil motor will be switched over here. After 10 seconds your auxiliary motor will be getting switched on. For that purpose only we are adding timer over here. T0 is added over here. Next rung we have termed our T0. T0 is called over here. After the 10 seconds our auxiliary main motor Y1 will be getting switched on over here. Then after we are adding the timer 1, that is will run for 5 seconds. Here we have given as K50, that is your 50 milliseconds. Up to 5 seconds it will be getting run. After that the second motor will be getting switched on. Y2 will be switched on here. That is explained over here. By using the two timers we are going to with a delay of 5 seconds and 10 seconds we are switching on the motors, and immediately Y naught will be getting switched on whenever the X naught is getting pressed. This is explained in this ladder diagram. Whenever you are going to switch the stop button, the 3 motors will be shut down automatically. Then next one is your function block diagram. This is a graphical blocks we are using to control this programming. By using this programming we can control the PLC. This is the function. In the ladder diagram we have represented in an left side rung and right side one. Left side we will be representing our contact and right side will be our output. Likewise here also the output will be represented in the right side and left side we will be representing our inputs. It will be in like a block. In the block left side will be our input and right side will be our output. This is the structure of our function block diagram. And these are the FBDs, that is the function block diagrams for logic gates. We have seen the logical gates in the ladder diagram. Here we will be representing in a function block diagram. This is how the inputs and the outputs are specified over here. For ampersand symbol will be used for an AND gate, and less than or greater than or equal to will be given to an OR gate. If the NOT gate is 1 with an inverse negated input will be given over here to inverse the input. Likewise the NAND gate, with an AND gate we have to going to introduce a negated input. Then in the NOR gate we will be representing the negated output or the inverse symbol for an OR gate. And this is used for by using an FBD we are going to comparing two inputs and multiplying with that, and we are going to representing as output. This is an AND gate representation. Second one is the figure 25 will represent the OR gate and figure 24 will represent the AND gate. And this is for your by using another inputs we can control the inputs, that is represented in an, that is the latching purpose will be done in the figure 26. The output will be compared with your input, so that the holding will be happened here, that is the latching it has been explained in the ladder diagram. The same operation will be done here also. Next figure 27 will represent the there will be 3 types of inputs: the start button, then liquid level which will be measured by an level sensor, next the reservoir will be getting maintained, and then these 3 inputs are compared, and based upon that the pump will be getting switched on or switched off based upon the condition used here. Whether it will be useful for you, I think so it will be useful for you, and it is an interactive section. Very much thank you for all. Thank you.